Hello, in this episode of To The Point Code, we'll be looking at version control systems. Our focus will be on Git and GitHub, and we'll go ahead to demonstrate how to manage a project using Git. Now to start with, let's talk about the version control problem. So whenever you're working on a project, changes are very important. You start with the files that you need for the project and you keep on making changes till you are satisfied with the output of the project. In the case where you have a client, you keep on making changes to the project so the client is satisfied with the output. It is very important to remember these changes because our clients can change their minds at any time. They might want us to go back to a change that we made some time ago, and this can be very difficult if we don't remember the changes that we made. At times, we might want to build different versions of our project so that we present them to our clients and they make their choice. All of this will be very difficult if we don't remember the changes that we've made to our project. So some people use strategies such as making duplicates of their project to serve as a solution for this problem, but this can only work well for small projects. This is because when you're working on a big project, it will definitely take a sizable amount of storage on your PC. Therefore, making copies of the project will only waste our storage space. This is the problem that version control systems help us to solve. So version control systems provide us with the tools that we need to manage our project over time. They make it possible to save the state of our project and also view history of changes that we make to them. It also makes it possible to revert or undo changes that we've made in the past. And in the case of large projects, version control systems make it possible for multiple developers to work on the code at the same time. Git is an example of a version control system. If you have heard of Git before, then you must have also heard of GitHub. Now let's clarify the differences between Git and GitHub. So when you talk about Git is a version control system. So Git makes it possible to keep track of the changes that we make to our project. So Git records changes in our projects as snapshots and provides them to us whenever we need them. Whenever a project is managed by Git, we call it a repository or a repo. This repo contains the history of all the changes that we've made to our project. On the other hand, GitHub is a hosting service for Git projects. So GitHub makes it possible to have remote access to our Git repositories. Now since GitHub is on the internet, whenever we push our Git repositories to GitHub, it becomes accessible to any other developer that you might be working with, regardless of their location. All they need is an internet connection and they can have access to our Git repository. This makes collaborating on a project very easy. So there is no need to make physical contact while trying to share code between multiple developers. Now to start using Git, we have to install it. Now to install Git, we go to the official website. The link to this site will be in the description below. Once the download has completed, we open and start the installation. For the most part, we will stick to the default settings. Once the installation is done, we can open Git Bash and check for our Git version. If we get a version back, that means Git has been installed properly. We can also check for the version on our regular command line. Now let's talk about some Git basics. First of all, to be able to take advantage of Git, we need to initialize a Git repository. We need to ensure that Git has been installed properly to proceed. So there are a lot of ways to make use of Git. We can make use of Git through a graphical user interface, but the most effective way to use Git is through the command line. That is the terminal on macOS and Linux, or the command prompt or even PowerShell on Windows. So for a new repository, we can create a directory, change into the directory, and use git init to initialize the directory into a Git repository. Let's demonstrate that quickly. So on the command line, we create a directory and call it my repo. We now change into the directory and use git init to initialize the Git repository. Once we do that, we will see that an empty Git repository has been initialized. Now we need to set user credentials to tell Git who is currently working on the project. To do this, we make use of git config command. We can choose to add a global flag to ensure that the credentials we provide will be saved and used for all other Git repositories that we'll create in the future. So let's head to the command line and set the credentials. In this case, I'll only set it for the repository, so I'll not use the global flag. Once we are done, I'll open the repository in the code editor and I'll copy a few files that I'll be using for the demonstration into the repository or directory. So we have an index.html file with some basic HTML code. We also have index.css file with some basic CSS styles and also logo.png file, which is just a logo that I'll be putting on our page. Now we open the work in a browser. So the work just displays the logo and also the text "Welcome home, buddy." We'll be playing around this text to demonstrate the various features of Git. Now let's talk about tracking the changes in our project. So the files that we have in our Git repository can have one of these three statuses. It can be untracked, it can be staged, and it can be committed. When the file is untracked, it means that Git is not monitoring the file for any changes that we make to it. When a file is staged, it means that we have told Git to keep track of any changes that will occur to that particular file. Now when a file is committed, it means that we approve of the changes that have been made to the file and we have saved it. Now to know the status of our files, we make use of Git status. Also, to add a file to the staging area, we use git add and the file name. We can also use git add period to add all our files to the staging area. Now to also make sure that a particular file is taken out of the Git workflow and there is no chance that we track it, we make use of the .gitignore file. Now back on the command line, let's check the status of the files in our repository. On doing that, we see that we have some untracked files in our repository. Now let's say we want to track changes to our index.css file. Once we do that and check for the status again, we will see that the index.css file is no longer part of the untracked files, and now Git is tracking it for changes. Now let's add all the other files to the staging area. Once we do that and check the status, we'll see that all our files are being tracked and we have no untracked files. Now let's create a notes.txt file in our project. Back on the command line, when we check for the Git status, we see that the notes.txt file is an untracked file. But what if we don't want to track this file at all? To do this, we go back to our repository and create a .gitignore file. Now in this .gitignore file, we put the name of the file that we don't want to track. In this case, notes.txt. Now once we've done that and we go back to the command line, checking for the status again, we no longer see the notes.txt file, but we rather see .gitignore, and this will take care of the file that we don't want to track. So now we add the .gitignore file to our staging area. Next up, let's talk about Git Commit. So as we've heard earlier, Git works by taking snapshots of the changes that we make in our project. It keeps these snapshots and provides them to us whenever we need them. So Git Commit is a way that we tell Git to take a snapshot of our project. To take a snapshot of all the current files that we have in our staging area. This means that if you want to make a commit, you have to ensure that all the files that have been changed have been added to the staging area. When making the commit, we can use the M flag to add an additional message explaining what has changed in our project. We can also use the A flag to commit the changes for all our tracked files. This means that without the A flag, the changes will be committed for only the files that have actually changed. Now let's head back to the command line and make some commits. So we use git commit and add the M flag to attach a commit message. Once the commit has completed, we can check for the status of our files again. Doing so, we see that there is nothing to commit and our working tree is clean. Now let's head to our index.html file and make a quick change. We will change our text from welcome home buddy to welcome home friend. Now back on the command line and checking for our status again, we see that now a file has been changed, which is the index.html file. We only made a tweak to the text, but in actual real-life project, you might want to write commit messages for important changes in the project. We are only using this for demonstration purpose, so we are not going to make any big change to our project. So let's assume that this is a good change that we've made and we want to keep. So we add it to the staging area and commit. Now once we've made a few commits, it is possible to see the history of our commits. This will be very handy when our project grows and we want to have an overview of the changes that we've made so far. Also, it is possible to have a look at how our project looked at a particular commit. Also, if you are not happy with a particular commit, there is an option to undo it by using the Git Reset command. Now back on the command line, let's use git log to have a look at the history of our commits. We see that we have 2 commit messages so far. Each of the commits has an ID and has details about the author and the date, and also the commit message that we supplied. Now using the one-line flag, we can have a simplified version of our history of commits. Now supposing we want to have a look at the state of our project at the first commit, we just copy the ID and use the checkout command. Now we see that the head has been detached. The head here is a pointer which refers to the current state of our project. Now when you have a look at the output of our project, we see that we have welcome home buddy again. Remember, we changed this to welcome home friend in our second commit. Let's also check out our second commit. Doing that and returning to the browser, we see that it has changed to welcome home friend. Now to get back to the state that we were in, we use git checkout master. We will talk more about this master later in the video. Now supposing we want to undo a particular commit that we made, we use the git log to get the ID of the particular commit, and we make use of git reset to undo the particular commit. Once we send the reset message, we are greeted with a Vim interface. This is common on the Unix systems. To exit this Vim console, we'll hit escape, W, kill and enter. Once we do that, our console will be a little messed up, so we need to clear it. Now checking for the log again, we'll see that an extra commit has been added for us, and this is the reset commit. It undoes all the changes and commits the new state of our project for us as a reset commit message. Now using Git Diff, it is possible to see all the changes that have occurred in our tracked files. If we add a staged flag, we'll be able to see all the changes in our staged files. Now supposing we've staged a file but we don't want to stage it anymore, we'll use Git Reset. This will take it out of the staging area and it will not be saved when we commit. Now to actually reset a file to its previous commit, we'll make use of the checkout once again. In this case, we use git checkout, double hyphen and the name of the file. Git diff is a very handy command as it helps us to see all the changes that have occurred in our files. Now if you made an accidental change, by running git diff, you will see this change and reset it. Now let's make some changes in our files. Now in the index.css file, we change the color of our text. This will give it a yellow tint. Now in the index.html file too, we add mine to the text. Running git status, we see that our files have been modified. Now let's add the index.html file to the staging area. On doing that and checking the status, we see that our index.html file is in the staging area. Now let's run git diff to see the differences in our tracked files. Doing so, we see that there has been a change in our index.css file. That is, our color has been changed from FFF to FFF777. Now running git diff again and adding the stage flag, we see the changes in our index.html file too. Now if we decide I want to take the index.html file out of the staging area, we can do that. We'll start with Git Reset. Once we've done that, we can check for the status again and we see that the file is no longer in the staging area. Now we want to reset the files to the state of their last commit, so we use the checkout command. Starting with the index.css file and checking for the status, we see that it has no longer been modified, meaning all the changes that we made have been cleared. Now let's do the same for the index.html file. Checking the status once again, we see that there is nothing to commit, meaning all the changes that we made have been cleared. Now let's talk about Git Amend. So Git Amend provides us with a way to modify our latest commit. With Git Amend, we can choose to modify the message of our last commit. Also, if we have made some changes to our project, but we don't want to create a whole new commit for these changes, we can fuse the changes with our previous commit by using Git Amend. To use Git Amend, we add amend as a flag to Git Commit and supply the updated commit message. Back in our code editor, let's modify our index.html and index.css files. Now running git status, we see that our files have been modified. So let's stage the files and commit the changes. Now in the commit message, we only talked about the color of the text. Let's say we forgot about the change to the text itself, and now we want to update the commit message to reflect that we changed the text too. Here we use the Git Amend. So we use Git Commit, add the Amend flag, and supply a new commit message. Once we do that and check Git log, we see that we still have the same number of commit messages, just that the last commit has been updated to feature the new commit message. Now let's talk about Git branches. So branching in Git is a way to make a copy of our working project so that we can make all the experimental changes to the copy, and once we are satisfied, we can come back to the main copy. While we are making the experimental changes to the copy, we don't risk breaking anything in our main copy. This is because the copy is a full repository on its own, so it is no longer linked to our main copy. The copy here is what is known as a branch. So the master branch is the main branch that we work on, and that branch should always feature the working code. Any other branch that we create can be given a name of our preference. Now typically, you will need a branch whenever you want to add a new feature to the project. Because it's a new feature, you don't want to risk destroying the working code of the project. So you create a branch for that particular feature. Whenever the feature is working and complete, you come back to merge with the master branch, which is the main code. Also, when there is a bug and you need to fix it, it is ideal that you create a branch so that it fixes the bug in the branch. Once you are done with that, you can come back to the master branch and merge it. Now to create a branch, we use Git branch and we supply a name to it. The name should describe whatever the branch is for. Note that the created branch will be an exact copy of our working code. Now to switch to the branch we created, we use Git checkout once again and supply the name of the branch to it. There is a handy shortcut to create the branch and checkout to it at the same time, which is Git checkout -b and the name of the branch. Also, to see the list of the branches that we have, we use Git branch. Now let's write some code. Now in our repo, we want to create a branch. We'll call this branch home text. This is because we want to modify the text on our home page. Running Git branch, we see that we have two branches, the home text branch and our master branch. The home text branch is highlighted because we have checked out into the branch. Now going into the code editor and looking at the bottom, we also see that the branch is being reflected over there. Now let's make a change to the text. We will change it to "this is home" for lack of a better expression. Now back on the command line and running Git status, once again we see that our file has been modified. Now we want to stage the change and commit it. Once we've committed a change, it has been saved to the current branch, which is home text. So now if we check out the master branch again, we see that the text on the home page is different. But coming back to our home text branch, we see that the text goes back to the change we just made. Now let's talk about Git Stash. So Git Stash provides a way to temporarily store all the changes that we've made to our project. It keeps it in the cache and we can retrieve it later. So with Git Stash, all our uncommitted changes, both the staged and unstaged changes, are put up in the cache for later retrieval. Meaning when you run Git status, you will no longer see the changes that were present. The command to do this is Git Stash. Back in our code editor, let us make a change and try out the stash. Running Git status, we see that we have some uncommitted changes. This is perfect for the stash. Once we run Git Stash and check for the status, we see that all our uncommitted changes are no longer present. This is because they have been cached by the stash. Now, how do we retrieve the stash? There are two ways to do that. First, we can use Git Stash pop. This will remove the files from the stashed state and put them back as uncommitted changes. Second, we can use Git Stash apply. So this particular one will remove the changes from the stash, but it will apply the uncommitted changes to all our branches. Therefore, if you visit any of the branches after using this command, you will see that they all have uncommitted changes. Now, suppose you want to put untracked files into our stash, you have to add the U flag or the include untracked flag. Now let's try to retrieve our stash using the Git Stash pop. Once we do that and check for the status, we see that our uncommitted changes are back and we can continue to work from there. Now let's put our changes in the stash again so that I'll be able to apply the other means to retrieve it. Visiting the master branch, we see that there are no uncommitted changes. Now let's come back to the home test branch and apply the stash. Checking the status once again, we see that our uncommitted changes have been released from the stash. Now I wanted to visit the master branch so that we can all see that the uncommitted changes have been also applied there. But I need to commit the changes in this branch before I can visit the master branch, which I don't want to do. So let's just put the changes back in the stash and move on. Now let's talk about Git Merge. So we have talked about branches and why we will need branches in our Git repository. We said that we will need branches whenever we create a new feature or when we try to fix some bugs. So the idea is that whenever we are done with the changes in the sub branch, we come back to the master branch and merge the changes with it. To do this, we first need to commit the changes in the sub branch and then we can proceed to the master branch to merge it. After the commit in the sub branch, we can check out to the master branch and use Git Merge to merge the branch to the master branch. Once we are done, we can get rid of the branches that we no longer need. To do this, we use Git Branch -d and the name of the branch. Let us demonstrate this. We are currently in the home test branch and this is how our homepage looks like. Checking the status, we have no uncommitted changes. Now checking out the master branch, you also see that we have no uncommitted changes. Now we can go ahead to merge the home text branch into the master branch. Once the merge is completed, we can see that the output of our code is the same as the output of the home test branch, meaning it has been merged into the master branch. Now once we are done, we can decide to get rid of the home test branch. We'll do that using Git Branch -d and supply home text to it. Now running Git branch, we can see that the only branch we have left is the master branch. Now let's talk about Git Merge Conflicts. So we have a Git Merge conflict whenever two different versions of the same file exist in two different branches and we try to merge them. Meaning, the same file has been modified in the two different branches and we try to merge them together. When that happens, Git fails to merge them automatically and we have to manually fix the conflict and commit the changes. So when we run Git merge and we get a conflict, we can use Git status to see the files that have been affected or the files involved in the conflict. Now let's try to set up a conflict in our project. To start with, let's create another branch. we'll call this branch text color because we'll use it to modify the color of our text. Now in the branch, let's go and modify the color of our text. Let's change it back to white. Once we've done that, let's stage and commit the change. Now let's check out to the master branch and make another change in the same index.css file. That is, change the color again. In this case, we'll get rid of the F's so that we have a shade of gray. Now once again, let's stage and commit the change we just made. Checking out the text color branch again, we see that there is a difference between the text colors. Once we've done that, let's check out back to our master branch and start to merge. We will do this using the Git Merge command and we'll supply the text color branch to it. And just as we expected, we have a conflict. Running Git status, we see that we have a conflict and the culprit here is the index.css file. It says that both have been modified. Now how do we resolve it? So first, Git provides us with some indicators in the file involved in the conflict so that we'll be able to identify easily the part of the file which is involved in the conflict. So the first indicator is a series of the less than sign. After this sign normally comes the pointer to the receiving branch. That is, in our case, it will be the master branch. The next indicator is the series of equal to sign. So this indicator has content before and after it. So the content before it is content from the receiving branch, and the content that comes after it is the content from the merging branch. In this case, it will be our text color branch. Also, there is a series of greater than sign, and after this sign comes the pointer to the merging branch. These three indicators make it easier for us to fix our conflict. Let's see how we fix it actually. So to fix the conflict, it all depends on us. We have to decide what we want to do. So first of all, we can decide to keep changes from the master branch only, that is the receiving branch. Also, we can also decide to keep changes coming from the merging branch. In this case, that will be our text color branch. Apart from that, we can also decide to make a different change which might incorporate the changes from both branches. So whatever we decide to do will fix the conflict. So we have to decide what change to make. Once we've decided, we need to get rid of the indicators that gets provided and also save and commit our changes. Let's get back to our work. Now back in the code editor, we see all these indicators that we just talked about. But in VS Code, it makes it a lot easier to fix the conflict. It gives us options as to which change to make. Once we do that using the VS Code, all the indicators will be cleared for us automatically. So in this case, I'm going to do that. Once we've done that, we have to stage and commit our change. Now visiting our browser, we see that our output is still intact. Now let's talk about GitHub. So as we mentioned earlier on, GitHub is a hosting service for our Git repositories. So that is, GitHub makes our Git repositories remotely accessible. So typically, after we've made changes in our local Git repository and committed these changes, we want to push our local repository to a remote Git server. An example of this is GitHub. Now we say this is not compulsory. This is because we can perfectly work with our local repository on our PC without pushing the code anywhere, and we can get access to all the essential features of Git. So to start with, we need to sign up or log in a GitHub account and then move on to create a repository. So in our browser, we visit github.com. If you don't have an account, you enter your email and sign up. Otherwise, you can just sign in. So once you've been able to sign in, you are greeted with this interface. If you have created some projects already, you will see your repositories on this page. Now let's hit the plus button and create a new repository. After we've done that, we supply a name to it. In this case, I'll call it my repo, and I'll provide an additional description. Now at this stage, we'll hold on and come back to it later. Now let's talk about cloning and pushing. So after we've created a remote Git repository like what we've done, we have two ways to proceed. First of all, we can clone the repository to our local machine and start making changes to it. This is called cloning. Also, we can initialize the local repository and connect our remote repository to it. In our case, we already have a local repository, so now we just connect the remote repository to it. We will use the git remote add to do that. So now to proceed, let's copy the link to our GitHub repository. Now let's connect our repository with it. Remember, origin is the name we give to our remote repository. Now if we check for the version of our remote, we see that our link is there. Now after we are satisfied with our local changes and commit, we now push the remote repository. To do this, we will use git push origin master. So as mentioned earlier, origin is the name we give to our remote repository. Master is the default branch that we'll be using, and also -u also tells Git to remember the parameters we are supplying to the push. So the next time you can just use git push to push our changes to our remote repository. Now back on the command line, let's push our changes to our remote repository on GitHub. If this is your first time, you receive a pop-up to sign into GitHub. Once you've logged in successfully, your work should be pushed to GitHub. Now back to GitHub and refreshing the page, we see that all our files are here. In addition to the files, we see our commit messages too. So once we have the code in the remote repository, it is very easy to collaborate with other developers and work on the same code base. Also on an individual level, you don't need to copy your code onto a flash drive or anything to have access to it on other machines. You can just go to GitHub and clone the repository to your PC. Now let's make a change and push back to GitHub. We will just change the color back to the yellow that we were using. Once we've done that, we stage the change and commit it. Once we've committed, we can just use git push to push the changes back to GitHub. You see, on this occasion, we are not asked to provide credentials because we've logged in already. Now refreshing the GitHub page, we see that our new commit message is appearing here, and it affected only the index.css file. Now lastly, let's talk about pulling. So as we've come to know, GitHub makes it possible and so easy for developers to collaborate on a single project. This means that a repository may have commits from multiple developers who are working on different parts of the same project. So as a developer who is part of such a team, you need to make sure that your local version of the repository is always up to date. And this is where Git Pull comes in. All it does is to compare your local repository to the remote repository. And if there are any changes in the remote repository, it will bring them down to your local repository so that you are up to date. After we pull, we can make use of the git def command again to see what has changed. In this case, we'll supply the head pointer to it so that it will show us all the changes after our last commit. Now let's try out the git pull. We don't expect to get anything because we have not changed anything in our remote repository. And after the comparison, it says that's already up to date, meaning our local repository is up to date with the remote repository. Now running git def head, we get nothing, meaning there is no change to worry about. And this brings us to the end of our version control tutorial, which focused on Git and GitHub. So we've learned a lot about Git and GitHub Basics. So from now, you should be able to manage your project using Git. So that's all for today. If you learned something from this video, please support my channel by leaving a like and subscribing. Thanks for watching, and I'll see you in the next episode.